Okay, let's try to use the rational roots theorem to actually find some factors. So here we have a polynomial with 5 terms. None of our old techniques work when we have 5 terms. We've got to use the new stuff. And now our new tool is rational roots theorem. Make a list of all the possible rational roots and then try stuff. So my leading coefficient is 4. The factors of 4 are 1, 2, and 4, but we can have the positive or negative versions of each. Our constant is 6. The factors of 6 are 1, 2, 3, and 6, and we can have the positive or negative versions of each of those as well. So we already have our table set up here. We're going to write every possible fraction with a p as the numerator and a q as the denominator. So 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, 6 over 1 is 6. 1 over 2 is a half, 2 over 2 is 1, 3 over 2 is 3 halves, 6 over 2 is 3. 1 over 4 is 1/4, 2 over 4 is a half, 3 over 4 is 3/4, and then 6 over 2 is 3 halves. So all of these ones that we could simplify, they had already showed up. So we don't need to include those twice. Our possible rational roots are positive or negative 1, positive or negative 2, positive or negative 3, 6, 1/2, 3 halves, 1/4, and 3/4. So we have a list of what? 16 possible numbers to try. We're going to go through the list and try things until we find at least one factor. Because right now we're just looking for at least one factor. Now, which number would you rather do arithmetic to? 1 or 3/4? 1 is the right answer. I am pretty much always going to try 1 first, because 1 makes my life easy. I'm using synthetic division for my trial and error because it's going to do 2 things. If the remainder is 0, I know I have a root, and then I will automatically know what the other factor is. So I start by copying the first coefficient, and now I multiply by 1, and I add. I multiply by 1, and I add. I multiply by 1, and I add. Oh, there's a 0. That's neat. Oh, wait, no. 0 times 1 is 0. I actually have a remainder 6. I got excited too early. So, since this number is not 0, 1 is not a root. Okay. Now I have a choice. I could try 2 next, or I could try -1 next. I'm going to choose to try 2. Let's see how that goes. First I copy the 4, and then I multiply. 4 times 2 is 8. and then I add. Negative 8 plus 8 is 0. 0 times 2 is 0. Negative 7 times 0 is negative 7. Negative 7 times 2 is negative 14. 11 plus negative 14 is negative 3. Negative 3 times 2 is negative 6. 6 plus negative 6. Oh, that's 0. The number 2 is a root, which means that x minus 2 is a factor. And then let's see the remaining factor. I had degree 4, go down 1, I have degree 3, and then I have 0x squared minus 7x minus 3. We don't write 0x squared. Even better, the degree of each factor is less than the degree of the original factors. Our new polynomials are in some sense smaller. There's just less to do to try to factor them. Now, 2 wasn't the only one that would have worked. 2 is not the only root of this polynomial. You should try and see what happens if you try negative 1 as your second number instead of trying 2 as your second number. You might get a different pair of factors. And that's okay. Right now we're only looking for just any factor. We just want to get started on this. We'll talk about factoring more fully a little bit later. But before we do that, in this problem we got lucky and we found a factor in only 2 tries. If we were less lucky, it might take us more times. So before we go to factor fully, let's take a minute and think about how we could narrow down all of these possibilities.